guten Tag. Thanks for coming to my session. Considering the other sessions that we have to choose from, this session is about infrastructure as code done right. It's not that I'm going to teach you how to do it, but I'm going to show best practices that you can follow. And my presentations, usually I start with a number and trying to wake you up. This number is 1,500,000, and you need to decide which of the options is the right one. It can be the annual visitors to Cologne Carnival Parade, or it can be the number of microplastics present in beer, or the raccoon population in Germany, or even the hard-coded keys and database passwords in infrastructure as code files. So who thinks is the A? 1, 2, 4. B? 1. C? 1, 2. D? Nice guess. Unfortunately, A is true. B is not true because it's 3 million, not 1.5 million. And it's the raccoon population in Germany, but also the hard-coded keys in our infrastructure as code files that from the sonar telemetry we have detected. I'm Jonathan Vila. I'm coming from Barcelona, and there we are famous for creating human castles, continuously building Sagrada Familia, and one day eventually we will finish it. Also, we are famous for our beaches and sangria and paella, and also for having amazing technology events like DevBCN. It's a conference that we run in Barcelona every year. We are also famous for some things in Barcelona, but for other ones too. But definitely we are super famous for beating Real Madrid 4 times in a row. Sorry for those Spanish guys that are from Madrid, but yeah, let me enjoy this moment. Okay, so I'm Jonathan Vila. I'm Java champion since 2020. I'm also one of the organizers of the Barcelona Java user group, and also one co-founder of JVCN Conf, and DevBCN is a conference that we run in Barcelona every year. For the last editions, we've had more than 1,000 attendees during more than 2 days. I've been developer for more than 30 years. I started using professionally Pascal and C, but I've used several languages. But I would say that apart from Java, the one that hits my heart is Delphi. Anybody has used Delphi before? Okay, I thought it was dead, this language. But apparently what it was that it was a developer, because I received a job opportunity 2 months ago for the Delphi developer. So I assume somebody died or got retired. I started with Amstrad CPC when I was 14, more than 2 weeks ago, definitely. And I used this x86 computer at the beginning, but now, as you see, I'm using this MacBook. So I'm a bit old. Now I'm working as a developer advocate for Sonar. Here you have a QR if you want to know more about me. Who doesn't know what Sonar is? Perfect. And the rest are Sonar users. Who is a Sonar user? Okay, makes everything easier. So Sonar, for both of you, is the company that is behind SonarCube. That is a static analysis tool that will analyze your code, more than 35 languages at the same time. And we have like one umbrella product, but then 3 products from the IDE. So you can use Sonar in your IDE, and it will cover 35 languages. SonarCube server, you can run it for free. Docker run, and it works. And also Sonar Cloud, that it is the SaaS version, that it's also free for open source projects, and also for private projects under 50,000 lines of code. So if you are not using it, please consider it, because it's free. So definitely worth to try. Ping me if you want to know more, or if you want to share your pains with your quality gates, your rules, whatever. Come to me and we can share our pains. Now, Sonar has bought 2 companies, well, in fact 3, but about AI, SCA, and now we can provide AI code fixes for your issues, and also we can generate SBOMs and also do vulnerability check on your dependencies. So this is the agenda for today. I will try to first introduce what infrastructure as code is. Then I will show some obviously benefits behind this way of deploying our applications, but some pitfalls that you can find in these files, best practices, and which are the issues that we found in Sonar telemetry regarding infrastructure as code. Sonar covers Terraform, Docker, CloudFormation, Ansible, so we collect some metrics about it. And finally, tools and methodologies. As always, I do not try to sell Sonar first because you have already bought it, so that's one point. And second, because there are several tools that you can try. So Sonar is only one example, a good example, but you can try others. So what is infrastructure as code? So basically, we have our application code that follows a flow. So we code, we submit, we check. Hopefully, you check the code. We test it, we submit it to our CVS, and then different pipelines are moving this application into our environments. But we have infrastructure as code, so in order to not deploy things manually, we have files that will automate that. So we are going to consider these files as code the same way. So we are going to lint them, to check them, to test them, to review them for all the issues that you can find. And then this will be submitted to our repository, and finally, using the pipelines, deployed the application code using the different environments. So this is the brief summary of what infrastructure as code is. The properties of infrastructure as code is basically it's machine readable. So our different artifacts in the pipeline are going to be able to read those files and interpret and parse and deploy or execute what is defined there. Usually, if you use declarative programming or approach, it is codifying the desired state, not the changes. So this is perfect because it will be idempotent. So that's very important. It's version, so we can just roll back our deployment to a desired state or version, and it can be reproducible anytime that we want. It is repeatable, so every time that we deploy those files, we are going to have hopefully the same state, and it has consistency across all the files. Well, because again, it's repeatable. So every time that we deploy those files, we are going to have the same state. It integrates with CI/CD pipelines. This is obvious. Most important thing is that it enables automation. So we don't have to be involved in the process of deploying an application. We can use GitOps, for instance, and every time that we commit something, it will deploy the changes and the application to the desired environments. The benefits, again, it's easy rollback. Rollback, we go back to the previous version of our code, and the same as with the application. We will have a different state in our environments. We don't have John, Michael, Susie, Sarah with permissions in order to deploy those artifacts, and also to have permissions in order to touch users' resources. It is a centralized system. It's not a user credential. What we are using is a system credential, what we are using. So everything is centralized and users are only committing changes to the repository. It's testable because, again, there is no human intervention, and we are sure that the flow is going to be always the same. It's not that we are deploying a Postgres database and changing permission or changing the schema, and we are doing things in a different order each time. No, this is going to follow exactly the same flow. Allows collaboration as any other code. It's any other code. You are going to have code reviews, pull requests, and so on, and checks, hopefully checks everywhere. And the important part here is also Git blame is gonna say who did the change. This is a spoiler for the chapter about AI. When you do Git blame, it never, never, never says Copilot. Never, ever. It says your user. Put that in mind whenever you are submitting or committing changes. It's never Copilot who is in the Git blame. And again, it's idempotent, so every time that you apply those changes, you are going to have the same result. But there are some problems. We can find misconfigurations in our files. We will see some examples later. We can expose your secrets, and you could say, but who is exposing secrets? A lot of people. There are lots of repositories with hard-coded secrets in Java code, for instance, or in infrastructure as code files. So this is also important and happens more than we think. Lack of testing. So we are deploying changes, and then we realize in production that something fails. So we should have dry runs. We should have ephemeral environments where we deploy our infrastructure. When I was working for Red Hat, we had a system with 8 layers. So we had 2 Postgres databases. We had Kie, that is a JVPM server. We had our Apache Camel application, and we had 2 different services from other teams. And we tested everything using, in this case, test containers in ephemeral environments. So every time that we committed something, everything was tested, everything was deployed. We were also using AWS S3, and you could say, but if you're using S3, that's not an ephemeral environment. Well, in this case, yes, because we were using fakes. We were using local stack. It's a super powerful tool in order to try. Who has used local stack before? Okay, so for the rest, local stack is kind of a mirror of several services from AWS, and you can run them locally, or in this case, in Docker in the GitHub pipeline. So that we were testing everything before deploying, even the exact same versions of each database, configuration files, and the other configurations regarding the services. There's another problem that we can experience, that it is giving too many permissions to a user or a system just because, yeah, it's easier, right? So if not, I need to take care of the permissions every time that that system tries to run something. We should use the system of the least permission. So just only giving the permissions that are needed, not more than that. But we can suffer from this. And we could think that the problems coming from infrastructure as code issues, well, those happen in some small projects, or yeah, I have a friend that has a friend that knows that one project failed for these problems. But no. Capital One, for instance, suffered from a big incident. It was a misconfigured AWS S3 bucket. And it impacted 100 million individuals. So, and I assume you agree with me that Capital One is not a startup, right? Uber suffered from hard-coded credentials. Come on, it's Uber. It's hard-coded credentials. So for sure nobody saw that? Well, apparently not. So they suffer from hard-coded credentials in 2017. But even Tesla had a breach where a lot of hackers were using their servers in order to mine cryptocurrency. Come on, this is not a small company. So if they suffer from that, I assume that we can all suffer from these issues if we are not checking them. So the common issues that we can suffer from are, in this case, incorrect settings can expose infrastructure. We have a public rate attribute here. And you would say, but who is putting public read into an infrastructure as code file? Okay, let me tell you a story, and then you can raise your hand if it has happened to you once in your life. Someone comes to you and says, hey, I have an idea. Oof. Then it's like, we are going to create this amazing tool, but we need to test if this is a good idea or not. So do it in 1 week. Fine. You do it in 1 week, and you say, but this is a POC, right? This is never gonna hit production. Of course. This is the biggest lie ever, right? So you start with a POC, you put some attributes that are working are allowing you to go directly to create that POC. But then things happen, and magically, some weeks later, you show that application running in production. And then you start thinking, oops, I think I missed some things into that code. So sometimes this is a flaw. Oh, who has experienced this? Yeah. So I assume that a lot of these issues are happening just because a lot of applications are following this path. We can also have hard-coded secrets. Again, we are connecting to an ephemeral system or a test system. So what's the problem of hard-coding a DB password? Then the application goes to production. And even worse, this code is public in GitHub. So yeah, what can happen, right? Then because we don't want to deal with network problems, we open everything. Yeah, and then one day there are several applications running, or there is someone mining cryptocurrency in your system. But there are also other problems that are not creating critical issues, but can definitely slow down the development process. That it is one team is using Azure Resource Manager, and another team is using Terraform, and another team is using CloudFormation or Ansible. And they are not treating the same arguments or the same variables the same way in order to deploy things, even to the same environment. So in this case, it's hard to spot that we are using different sizes for the virtual machine, right? So in this case, we are using standard DS1, and in this case, standard B1S. So it's even tricky to have it in mind. So it's definitely a problem that will impact the team. So, okay, now we have a picture of what is wrong. But what are the best practices to follow? Again, as anything, as any code, just do your checks, use a linter. Who uses a linter for infrastructure as code files? Is there anyone using a linter for IAC that it is not using Sonar? Right? For the rest, please use a linter. Whatever linter you want. There are several, even specific for Terraform or Ansible. Use one. I always say in my talks that the IDE is like Las Vegas. What happens in Las Vegas stays in Las Vegas. So what happens in your IDE never reaches the pull request. So it's better to fix the issues in the IDE, having a linter that will show up all the issues, all the inconsistencies that you have. And this will save you a lot of discussions or a lot of friction that can happen in a pull request. So use linters before committing. You can connect them into a Git hook, avoiding to the commit if there are issues. So there are different ways of doing this. Obviously, branching, well, you can even try to do trunk base, but I would say that most of the people are using feature branches. So yeah, follow whatever approach you want, but use Git or any other version control system and sign your commits. Especially, it's important. A lot of repositories, public repositories, request that you sign your commits before committing to them. So it's also important to sign all your commits and to avoid that people from outside your team can commit. Modular design, again, trying to have 20,000 lines of code for a Docker file or, I don't know, an Ansible file playbook. It's not the best idea. So divide all the files in smaller pieces, and it will help you. Use parameterization, right? Instead of hard coding things, it's gonna help you in order to scale your deployment. Use automatic testing, again, using ephemeral environments or unit testing, checking before committing, and using automation in order to connect this with your pipeline. So whenever you commit or to the main branch, this is going to be deployed to the environments. Regarding security, it's to put a lot of focus on secrets and vulnerabilities, and also privileges. This is going to save you a lot of time, problems, and for sure money if there is a breach in your system. It's important to have this in mind. But I agree with you that it is not easy to have everything in mind. So I need to have code quality, I need to have security, I need to check vulnerabilities, versions, several languages in order to define my infrastructure, and I'm not always up to date to the different use cases. So it's important to have something that it is constantly scanning our files. Tooling, rely on tooling. It's important to have observability in your environments. I'm not saying anything that you don't know, in order to also modify those files. So for instance, you can create deployment pods for Kubernetes. And sometimes, I hope it's only sometimes, we don't define the limits of our pods. But we should, because if not, one day we are experiencing problems because we didn't define the request limits or the limits for our pod. And then Kubernetes puts this pod in whatever node is free. But yeah, in 10 minutes of running the application dies because there is no enough memory. So we should have observability in order to define your deployment artifacts. Document your artifacts as anything, idempotency. So it's important that everyone that you run your IAC files, you get exactly the same result. Drift management, sometimes things change and it's not up to you. For that, at least in Kubernetes, we have operators that can change and redeploy resources or change our application considering different changes in the system. Kubernetes nowadays is full of operators for everything. And what they are solving is exactly that. So things can change out of your scope, but your application can react to those changes. So you need to have this in mind. And tooling, again, you need to rely on tooling. I will insist a lot, but you need to rely on tooling. Some of the issues that we have detected with Sonar regarding infrastructure as code. And you see that the first one, with more than 1 million issues, is OVH keys that are hard-coded in those files. So there are a lot of secrets, database passwords, hard-coded in those infrastructure as code. And we are not finding them very few times. We are finding them a lot of times. 1,500,000, so there's a lot. And I know for sure that those people didn't want to hard code those secrets explicitly, but they didn't have any tool that was helping them to avoid that. So I will tell you some issues coming from our rules that maybe can help you. In this case, as I said, Azure keys are disclosed, so instead of hard coding them, we should rely on parameters and a system that it is getting environment variables in order to add them. Limits, as I said before, when we create a pod, a deployment, specify the limits for the request and also for the running pod. This will save you from running issues, definitely. Don't hard code resource locations. So sometimes we are going to move our applications, our resources from different nodes. So don't hard code them. Just use, again, parameters and environment variables that will make it easy to move resources without touching anything. When we install, in this case, it's a Docker thing. When we install something in our instance, remove those intermediate artifacts that we have downloaded in order to install those applications, in order to save a lot of space from that. These are just only few of the rules that we have to cover this kind of artifacts in order to show you that there are a lot of things that we can miss. Sometimes we are giving too many permissions or options or power to those applications. So we need something that checks that we didn't sleep, as you can see here, the create verb for this resource. In this case, definitely we need to only give the verbs or the actions that this role can have. Don't give too many options on running power just to save some time. Wildcards are easy. Yes, I know. In order to not remember the name of the resource, the CRD, whatever. In this case, it's easier just to add wildcards, but we are going to suffer from this in the future for sure. In this case, sometimes our applications are running a lot of things and we have a massive log file. So we think, yeah, now I'm only interested on the logs created by this user. So I remove the admin user or the main user running the application because it is populating a lot of log lines. But we are going to suffer later from this. So it's better not to exclude any user from the logs and do it from the tool that we are using to inspect those logs. And what about AI? Is anybody using AI to generate IAC files? Perfect. So you can use Copilot or whatever other AI assistant to generate files. But Copilot is only right on the 29% of the time. So this is according to a study. So we have 20% of partially correct and 51% that it is wrong. So we cannot rely on AI. If you need to take something out from this talk, are two things. you cannot rely on AI, and you need tooling to code infrastructure as code files. It's important to use AI. That's fine. Use AI. But you need to be aware what you are using. It's not 100% right tool. So you need to review, always review the code. When you use Copilot, they have a message saying always review the code generated by AI. Definitely is super important. I did an experiment and I said, I want to generate a YAML file to deploy this application. This application is a Quarkus application. Who is using Quarkus? The rest are using Spring. Micronaut. Let's do. Let's be super brave. Helidon. Okay. Those that are using Spring, you should talk with the guys that are using Quarkus. This was an application in Quarkus that had two AI bots talking together. So I sent a topic, let's say. Let's talk about Germany. So one bot was asking the other about Germany, and with the answer was creating another question to the other bot, and I had a conversation. Depending on the model, the conversation was crazy. Depending on the model, it was interesting. I don't know. Well, I had this application running. So in order to deploy this application is to create a deployment with a Docker image. That's it. It's super simple. The thing is, with Copilot, it generated the Kubernetes YAML file. 6 issues. So specify a memory request, use a specific version tag for the image, specify CPU request, bind in resource auto-mounted service account to RBAC, specify storage request, and specify a memory limit. 6 issues introduced by Copilot in a very simple deployment file. With Amazon Q, it was better, just only 2 issues. But definitely using 2 different AI assistants, and in both cases, I had issues in the most simple file that you can create. So it's very important that using AI in order to help you to go faster, but not to commit that code generated to your repository. In terms of tooling, well, there are several tools that you can use. Definitely, in order to do infrastructure as code correctly, you can use GitOps with Argo CD or Argo Rollups or Feature Hub or Flagsmith. Well, there are tons of them. With multi-platform, you can have different files types like OpenTofu, Pulumi, Terraform, Ansible. Well, you can choose. These are only 4 examples. That's it. With validation, obviously, I put Sonar. But there are other tools too. Just check them. Check which is the best tool for you, but definitely use a tool. Use at least 2 tools. One in the IDE, that it is going to explain you why you have an issue, where you have an issue. And then another one that it is creating a quality gate, avoiding or breaking the build every time that you introduce an issue in your files. In order to test infrastructure as code, obviously you are going to check them with these tools, but also you can deploy to ephemeral environments like local stack, or even using emulators like Azure. There are other tools too that can help you in order to deploy in a safe way before deploying to production. In the SonarQube case, you are going to have the Docker file, and as any other file, it's gonna check and it's gonna give you the issue where it happens. In this case, we should quote the password in order to avoid problems. This is hard to spot, so it's important to have a tool that can help you on that. But in the SonarQube server, we are going to have exactly the same. So the issue in the in the server, in the dashboard. And then if it fails the quality gate, it's going to break the build, and it will not allow us to merge the code. In order to wrap up, code quality. But code is a verb. Code quality with infrastructure as code. Use tools. Put effort onto your code that you are submitting, and check, especially if you are using AI. These are the QR for the slides, the feedback. If you want to give me feedback, if it's bad feedback, perfect, I will learn from it. And also an article that I wrote about all this topic with more information and more details. And if you have questions, I'm here. Thank you very much.